So can you tell me what did we have for our symmetry for number 4? Okay. No? So this was the function x to the 4th minus 4x squared. Did this function have a symmetry?
Yes, the symmetry is on the y-axis.
Yeah, because it turned out to be an even function, right? Because both our exponents are even numbers, so we had an even function, bless you, which meant okay. What about its x-intercepts? What did we identify as the x-intercepts for this guy?
0, 0.
Okay, 0, 0. What else?
2, 0.
2, 0. And we had another one. Negative 2, 0. And where our graph was going to cross or just touch?
It's going to touch at 0, 0.
Okay, touches at 0, 0, but does not cross.
And then it crosses at both of the others.
Very good. Crosses at 2, 0. Crosses at negative 2, 0. Okay, and then what did we talk about? The leading coefficient test. So for the leading coefficient, this is of course an even and a positive coefficient. So what did that lead us to? As x goes to infinity, where was y going? Infinity. Was also going to positive infinity. And as x goes to negative infinity? Sorry? It was still going to positive infinity. Very good. And just as limits you would have limit of the function as x goes to infinity would be positive infinity, and limit as x goes to negative infinity, your function would still be going to positive infinity, right? Which meant both the arms of our graph will be going up. Basically, that's what the shape of this test tells us. And I believe that's where we had stopped last time. So let's talk about, we're going to need more pairs to come up with an idea of what this graph is going to look like. So one of the ordered pairs that we should try and find is the y-intercept. So to find the y-intercept, we make our x value 0, right? So our function is y equals x to the 4th minus 4x squared. So what do we end up getting as our y-intercept?
0.
Yeah, because you're going to end up with 0 minus 0. So the y-intercept actually is the same point that our x-intercept was at, right? Whenever you have 0, 0 as an x-intercept, by default it becomes your y-intercept also. So that's the only place on the y-axis where our graph will be crossing. So let's actually put this on a coordinate plane and let's see what kind of graph we're looking at. And we can then figure out what other points should we try and plot here. So we know we have our x and y-intercept at 0, 0, right? And then we've got 1, 2, 3, 4, 5, 6, 7, maybe. 1, 2, 3, 4, 5, 6, 7. Okay, then we have x-intercepts at -2, +2. I'm a little bit off there. Okay, that's all the information we have so far, right? We know our arms go up. We know there's symmetry with respect to the y-axis, but so far these are the only 3 points that I have. So what other points do you think we should use so we can get a little bit of an idea of the shape of our graph? So since we're using -2, I would probably use -3, -4 on the left-hand side. In the middle, I'd probably try and use -1 to try and see what kind of value I get over there. And then probably the same numbers on the positive side, so +1, +3, +4, and see what kind of ordered pairs we get through that. So can you tell me when we put this into our function, what do we end up getting? And then just using our X-intercepts, we have these ordered pairs also. So with -3 as our X value, what will we get? Yeah, it should come out to be a +45 because it's an even function, right? So even if you put a negative in, it ends up becoming positive. We also know there's symmetry in our function. So using that fact, +3 will also actually give you 45. Okay. What do you think we get with -4? 81? Yeah, because I'm thinking it should be a little bit larger than that, because you're going to be doing 4 to the 4th power, which is 256, minus basically 4 to the 3rd power, 192. 192? Which honestly doesn't really help us since we cannot graph either a 45 or a 192, but at least it gives us an idea of where our graph is headed, right? Now, what will we get for -1 and of course +1? With -1 or 1, you will actually end up getting a negative answer in this case. Yeah, you're going to get -3 because you actually end up with 1 minus 4. So that's -3 for both of these numbers. And I think that gives us a decent number of points to work with. So let's see. We've got our X and Y intercepts at -1 and +1. We're at -3, -3. At +3, we start hitting 45, which means we know we're going to be somewhere up there, right? As we get to -3, +3, -4, +4. So just as a general shape, we know at 0, 0, our graph touches but does not cross. So this arm of our graph is actually going down this way. So that's where it's touching but not crossing. And then it's actually going to go up, and it's going to be heading towards that 45 somewhere up there. And same thing with this point here. It's going to be going up like this. Now remember, this is not the exact shape of the graph. This is just a good graph, which gives us an idea of what the graph will look like. But if you actually look at the graph itself, this guy was x to the 4th power minus 4 x squared. This is actually what your graph looks like. So the first thing you should notice is that we're actually not turning at -1, -3, and +1, -3, right? Our graph actually goes down to the lowest point, which is at -4, and it's going to be -4 and +1/2, 1.5, and -1.5, right? If you look at these ordered pairs here. So almost -1.5 at -4, and this guy, of course, will then become positive approximately 1.5 and -4. So that means our graph needs to be modified where we bring it down to -4 and take it in, bring it down to -4. Take it in. Because, obviously we're not going to be able to get the exact graph because now technically those points were -1.414, +1.414, which is actually square root of 2. We cannot keep checking for all those tiny numbers. If you did, then yes, maybe you can get a better shape. So remember, the idea here is in general to get a good shape, a good graph, a general idea, but you're not going to get the exact same graph. So our graph is definitely a little bit different than what the actual graph would look like, but you can see we have the general shape, we have our x-intercepts, we can see where the behavior of our x-intercepts came out to be as we had predicted it would. It's touching at 0, 0, but not crossing, and it actually crosses at -2, +2. With the leading coefficient test, we knew both the arms of our graph would be going up, which is what we have. And of course, if we fold this along the y-axis, we'll see that symmetry happening, right? So all of those points that we went through initially will definitely work out. And of course, you can see this origin is the only place where we're crossing the y-axis at also. So that's our y-intercept. So a lot of those properties do in fact come out like we hope they would, but it's not going to be an exact graph. Now, can you tell me what the domain and range for this function will be? So the domain and range for this function. What can we say about the domain? Yeah, it's going to be all real numbers, -∞ to +∞. Very good. What can we say about the range? Yeah, so we've noticed in the graphing calculator graph, we're going down to -4. So you're going from -4 up to +∞, and of course we're including -4 in our range, right? Okay. Questions on number 4? Yes.
Are we going to have to provide the range for like all the graphs we do?
No, this is just, I'm just making sure you guys are in the habit of recognizing what the domain and range is, because on our exams, that's one question we're still not getting the correct answers on. So this is just for us to practice. But like you can see, there were no instructions on domain and range in the paper itself, right? All right, let's look at, we'll be doing the same thing with graphing here, but just using it as a means to solving a polynomial inequality. So we have talked about solving quadratic inequalities, and I think that was section 3.1 where we talked about it. So we're still using those same techniques here, just with polynomial functions. So we're going to see how the graphing method works, and then we'll come back and actually use the test point method, the same method that we did with quadratic equations. So again, we're trying to identify where this function is going to have values greater than 0. So the first thing we need to do is graph it, and we're going to be using these same techniques that we did with number 4. So let's start with number 5. So this is x to the 4th minus 200x squared plus 10,000. This is of course greater than 0 as inequality, but let's think about this as a function while we're graphing it. So again, let's start by talking about symmetry for this function. So will this guy be an odd function, an even function, or neither? Even, because again, you've got x to the fourth, 4 is an even number, x squared, 2 is an even number. And remember, for constant terms, we think of it as being x to the 0 power, which again, we assume to be an even number in this case. So all my exponents are even numbers. This is an even function. What kind of symmetry again does an even function have?
Y-axis.
Y-axis, yeah. So symmetric about the y-axis. And let's try and find its x-intercepts by making the y value 0. How are we going to do that? If I'm making my y value 0, that means we've got x to the fourth minus 200x squared plus 10,000 equal to 0. So how do we normally find x-intercepts? Oh, it can't be that hard. We use the quadratic formula, which we cannot do that here since this is an x to the fourth polynomial. So what can we use which might still be relatively easy to use? Yeah, factoring. It looks like factoring does not work, but actually it's going to be very, very easy. X to the fourth will of course break down into x squares. 10,000, how can we break that? Factors of 10,000 that add up to negative 200. Factors of 10,000 that will add up to 200. Because 50 times 50 is only 2,500. It's 100 because, you know, I guess check with your calculator. But 100 has 2 zeros, 100 has 2 zeros together, they make up 4 zeros, there's your 10,000. What kind of sign should I have in the middle? Yeah, negative. Since my middle term is negative, constant term is positive, both of these signs will be negative. So it's actually a perfect square trinomial because both my factors are the same factor. So you can write this to the second power. Come on. No, there we go. What does our x value come out to be? Okay, so if we're taking this to the second power, then of course that means I can do square roots on both sides. With the plus or minus. Our square and square root can cancel out, giving us just a 0. 0 of course does not take positive or negative sign. So it's not going to be just 10. It's going to be plus or minus 10 because we'll move the 100 to the other side. And then we'll have to take a square root again to get that x by itself, which again gives us 1 positive, 1 negative root. So that's going to be 10, 0, and negative 10, 0. Now you really have to think about this because we've done a lot of square roots at this point. What was the original multiplicity for these roots or x-intercepts? Actually, it's the second power. So each of these factors are appearing twice because 10 times 10 makes 100, 10 times 10 makes 100, and together those two hundreds make a 10,000. So each positive 10 and negative 10 is going to have a multiplicity of 2. Because remember, at the most, we should have 4 solutions, right? When we were talking about in chapter, section 3.2 or 3.3, we had talked about that. So that's where this is coming from. So each one of these have a multiplicity of 2. So what kind of behavior should we expect at these x-intercepts? Yeah, for both of them, it's going to be touches, but it does not cross. Alrighty, so we've got our symmetry, we've got our symmetry, x-intercepts. Now let's talk about the leading coefficient. So what do we have? Odd or even? Odd? Leading coefficient is coming from the x to the 4th, right? So that 4th power, is that an odd number or even number? Even. And is it positive or negative coefficient?
Positive.
Positive, because that's a positive 1, and that's an even number. So again, we have an even function or even power at a positive coefficient. So what kind of behavior do we expect from our leading coefficient test when it's an even exponent and a positive number? Yeah, they're both going up. I call it the touchdown, right? Because x goes to positive infinity, but y is still going up. X goes to negative infinity, but y still goes up to positive infinity. So for both of them, as x goes to positive infinity and as x goes to negative infinity, for both of them, y is still going up to positive infinity as your limits. So limit of the function as x goes to infinity is infinity, and limit as x goes to negative infinity is still infinity. So both our arms for the function are going up. Can we calculate the y-intercept? And what will that come out to be? Oh, we're making the x 0. So 0 to the 4th minus 200 times 0 to the 2nd plus 10,000. Yeah, your y-intercept is going to be at 10,000. So that's the ordered pair 0, 10,000, which will be really fun to draw. Yeah, we're going to have to get creative with our graph. Now, of course, you can find intermediate numbers and stuff like that, but we actually do have a little bit of a better idea of what this graph ends up looking like. But here's how we're going to have to modify our scale. And you know, normally we don't like to modify a different scale for our y-axis and a different scale for our x-axis, but there's just no way that we can get this graph if we try to do both of them on the same scale. So this is what we're going to do. For our x-axis, we're breaking these up into twos. So this will be 2, 4, 6, 8, 10. Same thing on the negative side, so -2, -4. I don't think I spread that out evenly. So in twos, so the fifth marker will be our +10 and -10. However, for the y-axis, because our y-intercept is at 10,000, we're actually going to break these guys down into 2,000. So our fifth marker will actually be 10,000. Like I said, it's going to be an interesting graph. Now we know at both +10 and -10, we have our x-intercepts. For both x-intercepts, we said it touches but does not cross. We have our y-intercept at 10,000. And just so that we know we're on the right track, what happens if we try to put, this guy will be -12 and +12 in our function. What does that number come out to be? Since you have symmetry, you can also just check for 12 and that would be the same answer for -12. Anybody come up with a number? Spencer? No? Shouldn't be. It should be a 4-digit number. Oh. Did you have something? 1,936. Yeah, 1,936. And like I said, because we have symmetry with respect to the y-axis, they'll be the same for both. So that's actually telling us that at -12 will be right about at 2,000, which will be somewhere over here and here. So the way it's going to work is we're going to be coming down this way to our x-intercept, touch, not cross, and we'll actually go back out this way. And of course, the same behavior will happen on this side. We're going to come down, touch the x-intercept, not cross, and go back out this way. Well, that's a really bad graph, but you get the idea. So that shouldn't be, actually I made that scale too big and that's why my graph is coming out looking like that. But just to show you, if we tried just using our little Desmos calculator here, we've got x to the 4th minus 200x squared plus 10,000. So if we try to bring those tens in, you can see just with this scale, we're not really seeing the entire shape of the graph. If we try and zoom out, we haven't even reached 10,000 yet. 2,000, 4, 6, 8, 10, 12. You can see what that graph ends up looking like, right? Just a really fat line. But if I actually zoom in to where that 10,000 is, we've lost the lines, but now we can see where it's crossing the y-intercept at. So that's the reason why we need to change the scale of our graph like we did. So at least we get the general idea of what the shape of our graph is going to look like, because otherwise, as you notice, we're not really able to get it all in one screen where you see that little W kind of formation of our x to the 4th function. So we'll talk about how to solve the inequality, but since we're on the graph at this point, just as a quick review again, can you tell me what the domain and range for this function will be? So what does that domain look like?
Negative infinity to positive.
Yeah, again, all real numbers, negative infinity to positive infinity. And what about the range?
0 to infinity, including 0.
Very nice, 0 to infinity, including 0. All right, so that was just a quick review. Now let's get back to our inequality. So basically they wanted to know where is the function value going to be positive at, right? And this is just greater than 0. So they don't want to know where the function is equal to 0. They just want to know where the function is greater than 0. So looking at our graph, what do you think will be the solution set for our inequality? So again, that inequality is x to the 4th minus 200x squared plus 10,000 is greater than 0. You can think of this as being your y value. So we're saying where is your y value going to be greater than 0? So what do you think that interval notation will be?
Is it going to have 3 parts?
Raven, say that again.
Is it going to have 3 parts?
What 3 parts are you thinking?
Well, like negative infinity to negative 10,
Okay,
because then it is equal to 0 at that point. But
so
then-
you're talking about this portion right here, the
Yeah.
left arm.
And then between negative 10 and 10.
Okay, so that's this little hill.
Yeah, and then above negative.
Okay,
Or I mean above 10, sorry.
above 10 to infinity, right? So we're thinking about this right arm over here. And what are you doing with the 10s and negative 10?
They won't be included because it equals 0 at that point.
Right, very good. So right at negative 10 and 10, we know our y value is 0, right? Because that's where our x-intercepts are. So we cannot include number 10 and negative 10 itself. We have to exclude them. So that's why it's going to break up our interval into 3 different portions. So from negative infinity to negative 10, but not including negative 10, because right at 10 it's equal to 0. And you can of course see this is a greater than inequality, not greater than equal to, right? So we cannot include the negative 10. So we stop right at negative 10, but then from negative 10 to positive 10, we have this little hill, which also has all positive y values. So that's going to be union from negative 10 to positive 10, again, not including the endpoints. And then again, we cannot use 10, which means start at 10 and go to positive infinity, not including 10. So very good. It breaks up into 3 parts where we have to exclude. Now, had they put that little sign of greater than equal to, how would this interval notation change? Yeah, because then we didn't need to worry about excluding our negative 10 and positive 10. It would go directly from negative infinity to positive infinity if they had put the little equal to symbol on that. Okay? Alrighty, guys, good job. Did anybody have any questions on number 5? No? All right, let's take a look at this last one, which is asking us to use the test point method. Okay, so remember, test point method is where we need to make sure that our terms are on one side, zeros on the other side, like we would do with any equation. And then we try to find our roots or our solutions, our x-intercepts, and put them on a number line. If you want to look at instructions for these, it's in your 3.1 handout. I believe it's the last page. Yeah, right there. We're pretty much following the same instructions that we did for quadratic equations or inequalities with the polynomial. So make sure you get 0 on one side, all the other terms on the other side, find your roots, which is your x-intercepts, put them on the number line, and then of course from each interval, we select a test point to see where our function will be positive, where it will be negative. All right, so this guy's already got 0 on one side. Okay, so this is x to the fourth minus 4x squared, and this is less than 0 using the test point method. So let's start by finding our x-intercepts, or you can think of them as your roots. Okay, so if we're finding the x-intercepts, you can think of this again as an equation. So x to the fourth minus 4x squared equal to 0.
Don't we just split it up into three?
Okay, how do we do that?
So you can take x squared out first.
Yeah,
So
factor
then
out
that
the
would
x
be
squared.
X squared times x squared minus 4.
Yeah,
And then you can factor x squared minus 4 down into x plus 2 and then x minus 2.
very nice. Yeah, because you've got x squared minus 4, which is a square on the x square, and of course 4 is a perfect square for 2. So that's your difference of squares. It's going to factor out into x plus 2, x minus 2. Didn't want to really do that. X plus 2, x minus 2. And remember, this is coming from our difference of squares. So if you have the first and last term that are perfect squares, oh, that should be an A. It factors into A plus B, A minus B. Okay, then you take each factor, set it equal to 0, which should give us our roots here. So from x squared equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. Is this problem starting to look familiar? Which one is it? Come on, buddy. What happens here? Square root, right? To get rid of the square.
It's the same as number 4.
It is the same as number 4. Yeah. So just go ahead, find your roots or your zeros or your x-intercepts. Okay, this is where we stop because we're not graphing these. We're using the test point method here. So we're going to take each one of these x-intercepts and put it on a number line, which of course represents our x-axis. So we've got 0 in the middle, positive 2, and negative 2. Now from each interval, we need to select a test point. So what can we select from this side?
Negative 3.
Okay, negative 3. From here,
Negative
negative 1. Here,
1.
positive 1. Okay, positive 3. Okay. So again, any test points as long as they represent the interval in which they are held in. So test point method means we take these numbers and plug it into our polynomial function. So that means we are taking x to the fourth minus 4x squared, and we're trying to see where we get positive values at, where we're getting negative values at. So let's check these test points. So we've got x equals negative 3. That's going to be negative 3 to the fourth power minus 4 multiplied with negative 3 to the second power. And what does this guy come out to be? It will be 45. And a positive one at that. Okay, if we use x equals -1 as our test point, -3. Because these guys will become +1 and +1 here, so that will be 1 minus 4, which gives us -3. X equals 1. It will be the same answer. And x equals +3. +45. And again, you can just plug these numbers in to verify that, but we'd already checked these actually in example 4, right? Okay, so when we use -3, we got a +45, which means all our y values are actually going to be positive in that interval. For -1, we got a value of -3, so that tells us in this interval, all our y values are going to be negative. For x equals 1, we again got a -3, so that means all our y values are going to be negative in that interval. And then the last one for x equals 3, we had a +45, so all y values are going to be positive in that one, right? So we now know in which interval the y values are going to be positive, which interval the y values are going to be negative, and we also know at the x-intercepts themselves, y values will be 0, right? So looking at our inequality now, what can we say about our solution set? So we've got our inequality as x to the 4th minus 4x squared, which is less than 0. So what will that solution set be based on our little number line here from the test point method? If your inequality is less than 0, which intervals should we be looking at?
-2 is 0 and 0 and 2.
Okay, and why are we breaking it off at 2? At 0?
I guess.
Rexy? No? Okay.
Because it touches the x. Wait, yeah, right? Because it touches x at 0?
It does.
Oh, and because it can't be equal to 0.
And because it cannot be equal to 0. Very good. So yes, from -2 to 0, my y values are negative. From 0 to 2, the y values are negative. Now, normally you would think, okay, well, shouldn't we be able to go just from -2 to +2 because both of them are right next to each other. But right at 0, at this point, my y value will be 0, right? And they're not saying that your inequality is less than or equal to. This is a strictly less than, so we cannot include the 0. So just like we saw in the previous example with our graph, this one will go from -2 to 0. We break at 0, union 0 to +2. And again, you'll notice at -2, 0, and +2, we're not including brackets because this is just a less than, not an equal to. If it was equal to, then we could have gone directly from bracket -2 to +2 with the bracket again. But since we're not including 0, we cannot use that. And I don't have the graph for this, but let's just use our Desmos here to do a quick check. And this is -4. Okay, so you can see only from -2 to 0, our graph has negative y values, and then from 0 to +2, again, our graph has negative y values, right? Right here at 0, 0, it's going to be equal to 0. At -2, it's equal to 0. At +2, it's equal to 0, so we cannot include our endpoints. So that should kind of give you a little bit of a visual on that. Alrighty, and you got some more graphs to look at for what the graphs of different polynomial functions look like. So you can go to page 309 of your textbook to take a look at those. Alrighty.